Now this set is going to be a little bit more work because we have to find the oxidation number of each species in the compound. So for some of them we'll have the rules, and for the rest we'll have to figure it out based on the sum total overall charge of the molecule. For this first one, oxygen is pretty easy. We have our rule for oxygen. It always has a -2 oxidation state. And then for nitrogen, it has to balance out the oxygen to give us a total of 0. So nitrogen has to be a +2. Next on nitrogen dioxide, oxygen is still a -2, always is, but now there are 2 oxygens to balance out, or a -4 overall, so nitrogen is going to have to be a +4. Next one is P2O5, oxygen still having a -2. And now this time to find the phosphorus, if you want to, you can think about it like the ones we did previously, where 2 times whatever the phosphorus is, plus 5 oxygens times -2 apiece, has to equal 0. So if you do the math out there, we'll get 2 phosphorus equal to 10, which means that the phosphorus has to have an oxidation state of +5. Next up is sodium hydride, and we know that ionic compounds always just follow their charges. Sodium takes on a +1 charge. And likewise hydrogen, when it's bonded to a metal, one of the rules is for hydrogen to have a -1 oxidation state. Those two add up to 0, so we're good to go. Now this is the dichromate polyatomic ion. Again, starting with the oxygen rule of -2. And this time notice that our overall is not 0, but it is instead -2. So 2 times the charge on the chromium plus 7 oxygens, each with a -2 oxidation state, has to equal the total charge, which is this time -2. So 2 chromiums is going to equal -2 plus 14, which is +12, which means that each one of my chromiums is going to have a +6 oxidation state. There we go, +6. Now moving on to the next column, we have tin bromide, and one of the rules that we do know about is halogens, that they generally have -1s. So bromine, we're going to say -1 oxidation state. 4 bromines gives us a -4, so the tin has to have +4. Now this next one, this is an ionic compound, so we'll start with the magnesium. And we know that in ionic compounds, magnesium has a +2 oxidation state. We also know hydrogen, that when it's bonded with nonmetals, it typically has a +1. And oxygen, again, has a -2. So now we can do the math to find the carbon. 1 times that +2 for magnesium. Let's tidy that up here. 1 times the +2 plus 4 times whatever the carbon ends up being, plus those 4 +1 hydrogens, plus 6 oxygen with its -2, and that grand total has to equal 0. Now if you add it up and you do the math, we've got 2 plus 4 minus 12 gives us -6. So we have 4 carbons minus 6 equaling 0, which means that each carbon has to have a 1.5. Now it's unusual, but it is still possible to have decimals on your oxidation numbers. In this case, carbon, 1.5. There we go. I'm going to erase this so we've got some room. Next one is H2CO3. So again, we have rules for carbon, we have rules for hydrogen, we have rules for oxygen. We're going to find carbon. Rule for hydrogen is +1. Rule for oxygen is -2. And so we can find carbon. 2 hydrogens times 1 plus whatever our carbon is, plus 3 oxygens, -2 apiece, grand total of 0. So that gives us 2 minus 6, or 4. So carbon minus 4 equals 0. So the carbon is going to be a +4. Next up is pH3. This one's pretty easy. Hydrogen with a nonmetal gives us a +1. And then if we have +1 times 3, that's +3. So to balance out and give a total of 0, the phosphorus has to be -3. Similar reasoning for the last one. Hydrogen is going to be, again, +1. And we can do this one using the math. 2 carbons. There we go. 2 carbons plus 6 hydrogens times an oxidation state of 1 multiplied there is going to equal 0, which means that 2 carbon equals -6, or 1 carbon has a state of -3.